Hello everyone and welcome to this lecture. In this lecture, we want to study about programming in general and also programming paradigms and some general concept like debugging. Then we will see a comparison of programming language and among them we will start learning about Python. In this lecture, we will just have an introduction of Python, like what is Python in general, applications of Python, what are the advantages of Python compared to other programming language, what are the tools of Python, IDEs and communities, and also we will study what is the future of programming. And in the next lectures, we will start coding, practical coding in Python. Let's start with the foundation of computing programs. A program can be defined as a sequence of instructions that specify how to perform a computation task. Just like following a recipe in cooking. In here, computer follows such step-by-step instructions in order to execute a task. Whether it's a simple arithmetic or even a complex artificial intelligence operation. But writing a program is not just about listing instructions randomly. This brings us to the programming. Programming can be defined as the process of breaking large and complex tasks into smaller subtasks and solve the subtask using one instruction. This makes problem solving efficient, organized, and easier to debug. Now, we can divide the programming language into two main types, low-level programming and high-level programming language. In the first category, low-level language like assembly, you can say, they are closer to the hardware and also they offer more control, but they require a deep understanding of the system architecture. These low-level programming languages are fast and efficient, however, very difficult to write and maintain. On the other side, we have high-level language. They abstract many of the complexities of the computer hardware and they make it easier for developers to focus more on problem solving rather than technical details. Examples are Python, C++, you can say Java, and many other programming languages. They are user-friendly and they are close to human language. It seems we can understand. It's close to the English language compared to the assembly, which are more codes, like you can say binary codes. Because of the simplicity and versatility of the high-level programming language, they are widely used in too many applications, like you can say data science, AI, web development, and many other fields. So understanding the difference between these languages help us to select the right tool for different programming challenges that we have. So now let's dive deeper into how we can leverage programming to solve real-world problems. Programming paradigms are fundamental style of programming, and these programming paradigms define how solutions to problems are structured and implemented using a programming language that we have. These paradigms guide how developers think about and write code. Programming paradigms are generally classified into two main groups. One is imperative paradigm and the other one is declarative paradigm. The imperative paradigm focuses on how a program should execute by defining a sequence of commands and steps. So in here, we follow a step-by-step approach. And we modify a program state through assignments and control structures. You can say like loops, conditions, etc. And in here, we have three subcategories. One is procedural programming, object-oriented programming, or you can say OOP, and parallel processing. In the case of procedural programming, we use procedures or functions to structure the code. Examples are C and Pascal. We have a very strong type of programming, OOP. In here, we organize code around objects and classes. Examples are Python, Java, C++. Next, we have parallel processing. In here, the focus is on executing multiple instructions at the same time, like CUDA and OpenMP. The second paradigm is declarative paradigm. In here, the focus is on what should be done rather how to do it. So in here, this paradigm describes the desired outcome and leaving the exact execution details to the underlying system. Functional programming is one of them. In here, we use pure functions, immutability, and also recursion. Examples are Haskell and Lisp. Then we have logic programming. The logic programming is based on formal logic, and in here we use rules and facts. An example is Prolog. Then the last but not least, we have database query language. In here, we use declarative queries to retrieve data. An example is SQL. Beyond this imperative and declarative paradigm, we have something called as hybrid paradigm. So many modern languages support multiple paradigms, and they allow developers to use different approach within the same language. For example, Python, JavaScript, Scala, and etc. No matter how skilled a programmer is, errors are always there. And normally they know them as bugs. So programming errors are known as bugs. We can say a bug is simply a mistake in a program that prevents it from functioning correctly. These errors can range from simple typos and to complex logical issues. They are very difficult to detect. So to fix these issues, we need to go through a process that we call it as debugging. So in debugging, we want to identify, analyze, and correct errors in a program or bugs in a program. So debugging is an essential skill for every programmer, as even small mistakes can cause major problems in the software. There are different types of bugs that we commonly encounter, including syntax error, runtime error, and semantic error. First, we have syntax error. These syntax errors occur when the rules of programming language are violated, like missing a semicolon in C or incorrect indentation in Python. Even a simple mistake of adding space in Python code make a problem. So this syntax error prevent the program from compiling and running at all. Then we have runtime error. This occurs while the program is running. So a common example for runtime is dividing by zero or accessing an invalid memory location. Unlike syntax error, runtime errors may not be immediately visible and they require careful testing to detect. Finally, we have semantic error. They are trickiest to catch. These semantic errors occur when the program runs without crashing, but it does not produce the correct result due to the mistake in logic that we had. For example, using the wrong formula in a calculation. This might not cause an error message, the code run, but the output is not what we want. Understanding these different types of bugs help us to become better at debugging. So by systematically identifying and fixing these errors, we ensure our programs run smoothly and efficiently. As I said, we have too many programming languages, and it's not easy to say which one is better than another one. In this slide, I want to compare the programming language based on getting a job in 2025. If you just want to get hired, the Python has the most opening job of any other language in this list. Python has too many job requests and too many people they want to hire Python programmer. And compared to 2024, this red line is for 2024 and green one is 2025. You can see Python also is increasing compared to SQL, Java, JS, C++, C Sharp, etc. So Python is, we can say as of 2025, is the most interesting and powerful programming language among the others. So let's talk about this Python as the most popular and versatile programming language in the world as of 2025. Python is called as interpreted. It means it doesn't need compiler, but it needs an interpreter. Then it's a high level. It's close to human language. It's like English writing. And also general purpose. It means it can be used for different kind of application. Python does not require compilation before execution. That's why we say it's interpreted based. Python provides a high level abstraction to make programming easier, and it can be used for different kind of applications from web development to AI, data science, and also automation. This language was proposed by Guido van Rossum. He is a Dutch programmer, and Rossum wanted to design a language that was easy to read and write, yet powerful. He said, I want even a kid can write a code. This Python was released in 1991, and over the years it has grown into one of the most widely used programming language in the world. Python is simple, it's readable, and because of this advantage, it's an excellent choice for beginners. But it's powerful because of its powerful libraries and powerful frameworks, so it's also favorite among professionals. Whether you are working on a machine learning, cybersecurity, software development, Python is a tool that can adapt to your needs. So as we move forward, we will explore what makes Python unique and how we can use it efficiently in programming. So what are the Python applications where it can be used? As I said, Python is one of the most versatile programming language and its applications span across multiple domains. Let's explore some key areas where Python is widely used. First is web development. Python plays a major role in web development. Framework like the Django Flask makes Python easy to build scalable and secure web applications. Next, Python is widely used and you can say it's a dominant force in machine learning and AI because of its very strong, powerful libraries like TensorFlow, PyTorch, Scikit-learn. So these libraries enable developers to build powerful AI models. Python is also used for console-based applications and it allows developers to create interactive command line tools and automation scripts. When it comes to the software development, Python is a popular choice for building applications due to its simplicity and efficiency. In the field of scientific and numeric computing, Python excels with libraries like NumPy, SciPy, Pandas, and these libraries makes Python preferred language for researchers and data scientists. Python also is widely used in business applications such as ERP and CRM systems and organizations. They can simply manage data and automate process. In the case of audio and video based applications, Python provides tools like OpenCV for media processing and streaming. Even in 3D CAD, computer aided design, Python is used in software like FreeCAD for designing 3D models. Enterprise also rely on Python for enterprise applications including automation, cloud computing, and DevOps tools. Finally, we have image processing. This image processing is another area where Python shines, thanks to powerful libraries like OpenCV and Pillow. So with such a wide range of applications, Python proves to be an essential language for developers, business, and researchers alike. No matter what field you are in, Python has something to offer to you. Now that we have introduced Python, let's dive into some of the reasons why Python is one of the most popular programming languages today. First and foremost, Python has a simple syntax. It means very similar to English language. This makes Python easy to read, write, and understand, even for beginners. Python runs on interpreter system. It means code is executed line by line, and this makes debugging and testing much easier compared to other languages that they need compiler. Another major advantage of Python is the vast collection of inbuilt libraries. Too many inbuilt libraries there are. These inbuilt libraries provide ready-made functions for tasks like data analysis, web development, machine learning, and automation. So these help developers to save time and effort. Despite the power of Python, it has a moderate learning curve, making it accessible to both beginner and experienced programmers. It is also highly flexible and easy to integrate with other programming languages like C, C++, and Java. And Python allows developers to quickly create prototypes, especially useful for startups and research projects. It's free and open source, Anyone can use it, modify it, and contribute to the development of Python. Python follows object-oriented programming paradigm. This enhances code reusability and modularity. Another key advantage of Python is portability. Python code can run on different systems with minimum changes. Windows, Mac, Linux, or anything. With all these features, Python significantly boosts developer productivity by simplifying complex programming tasks. Finally, Python is platform agnostic. It means we can write our code once and run it almost anywhere without compatibility issues. So here in this picture you can see comparison of Python and C. For example, teacher asks a student write sorry 100 times. In C we have to include studio, include canio, then we define main function, this is the input, this is the output, then integer counter n is equal to 1 while n is less than 100, then print sorry. But in Python, very simple, print sorry dash n for new line, multiply 100 times. So you can see how easy it is. Python is widely known for its versatility, and one of the biggest strengths of Python is the vast ecosystem of tools and libraries that are available for different applications. Let's take a look at some of the key areas where Python excels and tools that make it possible. First, we can see data science. Python provides pandas, numpy, sympy, ipython, plotly, and many others. These tools help data manipulation, numerical computing, scientific analysis, data visualization, and these all together make Python the go-to language for data professionals. When it comes to the machine learning and AI, Python leads the way with frameworks like TensorFlow, Cras, Theano, Scikit-learn, PyTorch, etc. These powerful libraries provide advanced algorithm and deep learning capabilities for everything from predictive analytics to neural networks. For GUI development, Python offers several libraries like Kiwi, Tinter, and many others. These tools allow developers to create interactive and user-friendly desktop applications easily. In case of automation testing, Python has a strong presence with frameworks like Robot, Behave, and many others you can see here. These tools are used to automate software testing and help developers to do the job fast and more efficient. Python is also a popular choice in game development. Pygame and Friends. These libraries are used for 2D, 3D games and handling graphics easy, physics, and game mechanics. Then for image processing and computer vision, Python offers libraries like OpenCV, Pillow, and many other friends here. These are widely used for facial recognition, medical imaging, and also advanced image editing. And finally, web scraping. Python shines with tools like Request, Beautiful Soup, Selenium, LXML, and Scrappy. Developers easily can use this tool to extract and process data from websites efficiently. So with such a rich collection of libraries, Python continues to be dominant force across multiple industries. Whether you are working on AI, automation, data science, or web scraping, Python has the right tool to get the job done. To write and execute Python code efficiently, we need to have both Python installed and also we need one IDE. IDE stands for Integrated Development Environment. So these are somehow a code editor. We can write, debug, and run our programs. Choosing the right IDE is crucial for an efficient and productive coding experience in Python. So in this slide, we want to explore some of the most popular Python IDEs and editors that are used by developers, data scientists, and researchers. First, we have Colab. Colab also, it's by Google Colab. It's a cloud-based. It means you don't need to install anything. Just you search on Google Colab, then open it, use your Gmail account and start coding. Coding online. You don't need to install anything. So users can write and execute Python code in a web browser. Google Colab is widely used for machine learning and data science because of its built-in GPU and TPU, because they provide you GPU. The code are executed on Google servers, not on your local computer. Next is Jupyter. Colab, you can say somehow it's an online Jupyter. So this Jupyter Notebook is a powerful tool for interactive computing you can install on your computer, but for heavy machine learning programs you need to have GPUs. So Jupyter allows users to combine live code, equation, visualization, and also text in a single document. It's a favorite among data scientists and educators. Next, we have Spider. Spider is a scientific Python development environment and it is specifically designed for data science and research. Spider comes with built-in tools for data analysis, debugging, and visualization. Next, we have VS Code or Visual Studio Code. It's a kind of lightweight but powerful editor with extensive support for Python through extensions. This VS Code offers features like debugging, the version control integration, and many other options. Then we have RStudio. RStudio is primarily known for R programming, but also it supports Python. RStudio is used by data scientists who work with both language R and Python, and they need a seamless transition between R and Python. Then we have PyCharm. PyCharm is also known as a professional grade Python IDE. PyCharm was developed by JetBrains and it's one of the most feature-rich environments. PyCharm provides intelligent code completion, also debugging. Deep learning is supported, so it's a kind of a top choice for developers. Then we have Notepad++, also Sublime. These are lightweight text editors. They support Python development through plugins. So these Notepad++ and Sublime, they are great for quick scripting and general purpose programming. Then we have Vim and Emacs. They are highly customizable and powerful text editors. And also we have MATLAB, but it was, originally for numerical computation, but it also allows Python integration. And recently also we had Python in Excel, Microsoft Excel you can use. So with so many options available, selecting the right IDE depends on your workflow and also project requirements. Whether you are into web development, data science, or scripting, Python has an IDE that suits your needs. The first one that I want to introduce more in details is Colab. Colab or collaboratory Google Collaboratory. It's a kind of powerful tool for Python programming. And normally machine learning people and data science use it a lot. It's a Google research project and they designed for democratize machine learning education and research, and they provide an accessible and collaborative environment for coding. Colab is a Jupyter based notebook. You can say it's online. It means we can write and execute Python code in an interactive and structured way. One of the biggest advantage of Colab is that it doesn't need to any setup. Simply you open the browser, and if you have a Gmail account, you can do it. Another major benefit is that Colab provide free access to GPU and TPU. So it's excellent choice for deep learning, data science, and high performance computing tasks. And best of all, it's free. If you search for Google Colab, you can go to this website and there you can use it. So when you go inside, you can see the Google Colab. Here is the name of the program. In the next lecture, we will start real coding. Just this is a screenshot, and here you can write the code, and here you can see the result, but it's all online. So in the next lecture, I will explain in details. The next one is Anaconda Navigator. If you want to do coding offline on your computer and not on cloud, then you may use Anaconda Navigator. Anaconda is based on Conda. Conda is an open source cross platform and also language agnostic package management system. In simple terms, it helps install, manage, and update Python package effortlessly. Then to use that, we have Anaconda Navigator. It's a free and open source environment, and this is specifically designed for Python programming as well as R programming. Anaconda is widely used in data science and machine learning application. Why? Because it simplifies package management and environmental setup. So here you can see Anaconda Navigator, Jupyter is here, Jupyter Lab is here, Jupyter Notebook here, Spider is here, RStudio, VS Code. So in the next lecture, I will explain how to install it and how to use it. Then we have a Spider. A Spider is also a part of this one. You can see here. A Spider is one of the most popular Python IDEs, and it's especially for data science and scientific computing. So a Spider is a sort of scientific Python development environment. It's an open source IDE, and it provides a powerful interactive coding experience with features like syntax highlighting, debugging tools, a variable explorer, and real-time code execution. Spider is particularly useful for researchers and data analytics because it integrates seamlessly with popular libraries like NumPy, SciPy, Matplotlib, and Pandas. Then here you can see the environment of Spider. You can write your code here and you can see the output here. In a separate section, I will explain how to install it and how to code it. Now I want to explain two famous Python libraries for machine learning, including TensorFlow and Cross. The first one is Google TensorFlow. Tensor is a container which can be house of data in n dimensions. So we have vector, we have matrix, and we have tensor. TensorFlow or TF is a Python-friendly open source library, and it is used for numerical computation, and machine learning with TensorFlow will be very fast and easier. So TensorFlow allows us to create data flow graphs. What is data flow graphs? The structure that describe how data moves through a graph. So TensorFlow was developed by Google Brain, and It was released in 2015 and it can run based on CPU and GPU. Both of them is okay. Its flexible structure allows for the easy deployment of computation across a variety of platforms. The next one is Cross. Cross is a powerful and user-friendly deep learning library written in Python. Cross acts as an interface for TensorFlow. And it makes it easier to build, train, and deploy deep learning models. Cross is known for its simple and intuitive AI. It can easily help us to quickly prototype neural network with minimum code. With 5 or 6 lines of code, you can code neural networks. It supports convolutional and recurrent neural network as well. And one of its key advantage is that it abstracts complex deep learning operations. And it's accessible even to beginners while still being powerful enough to advanced users. Every programmer should be aware of two communities, Kaggle and GitHub. Kaggle is an online community. Kaggle is a vibrant online community where data scientists, machine learning engineers, and people they come together to learn, collaborate, and compete. So Kaggle provides a powerful web-based data science environment, and users can find and publish data sets. They can explore and build models. They can work on real-world machine learning problems. And one of the Kaggle's key attraction is its competitions. In here, participants solve challenging data science problems to gain experience, recognition, and even rewards. So the address is available here, kaggle.com. The next one is GitHub. GitHub is a powerful platform for vision control and collaboration, and it is widely used by developers and data scientists. It's based on Git. Git is an open source version control system, and Git helps to track changes in a code. And because of that, it is easier to collaborate on projects. So with GitHub, multiple contributors can work on the same project. And it is an essential tool for open source development. And GitHub also provides features like repositories, pull requests, issue tracking, and with these options, it is an all-in-one hub. You can say all-in-one hub, all-in-one hub for software development and project management. So, what is the future of programming with this AI ChatGPT? The future of programming is rapidly evolving nowadays with like AI driven development tools. AI is streamlining coding by automating repetitive tasks and also assisting in debugging and even generating code snippets. At the same time, the rise of low-code or no-code platforms is making software development more accessible and also enabling non-programmers to create applications with minimal coding. Looking ahead, quantum computing is said to revolutionize the field by introducing new paradigms that could solve complex problems at unprecedented speeds. Additionally, automation and AI will continue to play a crucial role in software development, optimizing workflows, improving efficiency, and reshaping how we build and interact with technology. As these trends unfold, programmers must adapt, embracing new tools and approach to stay ahead in the ever-changing landscape. One question is here, will AI replace programmers? This is a question that sparks a lot of debates. While AI is advancing rapidly and tools like GitHub, Copilot, and ChatGPT can assist in writing code, debugging, and automating tasks, they cannot replace human creativity. This is very important, human creativity. Human creativity, critical thinking, and problem solving is still human exclusive. AI enhances productivity, but it still requires human oversight to ensure accuracy, efficiency, and ethical consideration. Instead of replacing programmers, AI is reshaping the industry, creating new opportunities in AI driven software engineering and allowing developers to focus on more complex, strategic, and innovative aspects of programming. The future is not about AI replacing human. It's about human and AI working together. Human AI collaboration, human and AI working together to push technology forward. So here are some of my advice for programmers and beginners. For anyone starting their programming journey, my biggest advice is to focus on mastering the fundamentals, especially algorithms, data structure, mathematics, because they form the backbone of efficient coding. The tech industry evolves rapidly, so it's important to stay updated with emerging technology and trends. One of the best ways to improve by working on real world projects and contributing to open source communities, as hands on experience enhances both skills and confidence. But remember, programming is not just about syntax, it's about problem solving and critical thinking. Developing a mindset that embraces logical reasoning and creativity will set you apart. Lastly, never stop learning. Technology is always advancing, and continuous growth is the key to long term success in this field. So, in conclusion, programming is constantly evolving, driven by advancement in technology and automation. While AI is transforming the way we write code, it will not replace programmers. It will enhance their capabilities. Human expertise like creativity, problem solving, and critical thinking, they remain irreplaceable in software development. To stay ahead, it's crucial to keep learning, experimenting, and adapting to new trends in the field. Embracing change and innovation will ensure that we continue to thrive in this ever evolving digital landscape. Thank you very much for your attention. In this lecture, we learn about general programming, types of programming paradigms, debugging, then we compare programming language, and then we studied about Python, Python application, Python advantage, tools, IDEs, communities, and the future of programming. In the next lecture, we will start practical programming. Please feel free to ask me if you have any question via this email provided here, and see you in the next lecture. Thank you.